Hi, folks. Today we will talk about an interesting topic called nested classes, which are used in a lot of projects. Mainly, we will try to get some insight into the difference between static and non static nested classes. To begin with, what is a nested class? Most classes that we define are top level classes. The file name and the class name match. But Java provides us with a way to create a class within a class. Now, why would we ever want to do this? There are many different reasons for this. For example, sometimes a class is relevant only to one other class. So, by declaring it within that class and making it private, such a class will not be exposed to other classes, but can still be used within this class. That's a great example of encapsulation. You may also group related classes of a component as nested classes within that component. That's another example. Let's take an example of a static nested class. On the screen, you see a top level class called parent. It has two member variables, first and last, and also has a constructor. But you also see a nested class called child. And note that this class is marked as static. Static simply means that you can instantiate this child class without instantiating the parent. And the name of this child would actually be parent.child if you're using it outside of the context of this class. Now, this child class has only one member variable called first. Now, note here that even though the method name is called getFullName, it is only printing the first name, and we are going to fix that later. Now, the only reason that this child class is within this parent class is that they are related in some way. This child could well have been defined as a top level class and defined in a separate file. But because it's the same component as the parent, we decided to put it inside the parent class. But this static child class has no implicit access to the parent. In fact, that would not even make sense because the parent may not exist when we are creating this child class. Now, how do we use this parent class? We just create a parent object and then call the method to create a child. You can see the output of what you see as Jim. That's an expected output. Now, because the child class is a static, we should be able to create the child directly. Now, what's the output of this? It prints the output of Jake. Now, what if I want to print the actual first name? For this, the child object would need to access the last member variable from the parent object. But with this approach, where we mark the nested class as static, I cannot access the last name of the parent because the child does not know about the parent's existence. But from the use case perspective, the fact that the child can be instantiated without instantiating the parent does not make sense. So let's change the child class to include the parent as well. So here's one way to fix the problem, and we will come to a better way of doing this very soon. Here on the screen, you can see that the child class has been modified to take the parent class as a part of the constructor. This makes perfect sense because a child cannot be created without a parent. So we added extra code to insert the parent into the child. Now you can also see that the getFullName has now been modified to access the private member of the parent, the last variable. Now when we run these examples, we will get the full names, as you see on the screen. It will print Jim Doe. We can still create the child, but this time we are forced to pass the parent as a parameter. And that's the correct behavior. But do we need to make all of these changes? It turns out that there is a better way to fix the problem. Instead of us manually passing the parent as a parameter, Java provides us a way of doing this by simply removing the static keyword from the child class. By removing the static keyword, the child class is now called an inner class of the parent. the compiler will not allow a child class to be created outside the context of the parent. So here's an example where we removed the static keyword from the child class definition. What does this do? It means the child class cannot be created without the parent class already instantiated. Also, the child class can access the parent's member variables directly. That's an important thing. In fact, the compiler is going to automatically add a member variable to the child class which points to the parent class. It also means that the child class can be instantiated from within a non-static parent method only, because only then can we guarantee that a parent object exists. With this change, let's run our famous examples. The child name that will be printed is Jim Doe, as you can see on the screen. Now, if we try to do this, trying to instantiate a parent.child from another class or from a static method, it will give a compiler error. Now, we also mentioned a while back that the compiler will automatically add a parent member variable to the child class. Now, let's confirm this. How? Java provides a command called java-p, which can disassemble a class and let us see the insides of the class. If we use the java-p command on the child class, what should we see? Assuming that this child class is a non-static nested class. First of all, the name of the child class that it creates is parent$child.class, as you can see. And that's what we are doing java-p on. We see that the compiler has added a parent member variable, the line in red. But of course, we will not see this auto-generated parent member for a static nested class, because a static nested class does not know of the parent's existence. It's not designed for that. So in summary, the difference between a static and non-static class is quite subtle. We should use a static nested class if we want the child to not be associated with the parent, and we don't need access to parent's member variables. But we should use a non-static nested class, which is also called inner class, if the child class needs access to parent's member variables. In other words, the child cannot be created without the parent. Now, in many cases, we may be using non-static classes even though we should be using static classes. This may appear to work, but it's simply inefficient if there is no need to access the parent members. I hope this video has been useful to you, and if you like what you hear, do not forget to subscribe to my channel. I have a lot more such videos for you to enjoy.